A very good day, everyone. My name is Lorothy Morrison Singkang. I'm from Polytechnic Mukah, Sarawak. Today, I'm going to present my work with the title Perceptron-based UHF Smart Sensor for Corona and Arc Discharge Localization. This is the overview of my presentation. Begins with introductions, problem statement, objective, some literature review, methodology, result, and lastly is the conclusion. Corona and arc electric discharge constitute a significant threat to electrical safety, the power apparatus, and the stability of the power system. This is due to the aging and the insulation degradation in power apparatus such as circuit breaker, power transformer, switches, transmission cable, and so on. Therefore, the pre-monitoring is important as an early preventive approach, and it must be performed effectively to prevent pre-fault threat and system breakdown. Finding the weak insulation region requires precise ED source localization. So due to this, accurate and speedy localization technique have become the focus of ED diagnosis for power apparatus. There are many significant methods for ED localization. However, the application and the implementation still depends on the nature of the faults. Okay, so therefore, when it comes to the accuracy, different measurement method may have advantages in various applications for power equipment, because different type of ED may provide different diagnosis for the severity of a damage when the ED is happening. Next one is the problem statement or the gap that encouraged me to do this work. Okay, so although recent development system include a very high performance, very efficient and smart characteristic in the insulation condition monitoring, for especially for ED detection, localization and recognition. However, there are still constraints in implementation. Okay, this is due to the high cost and the complexity of the system itself. In some cases, multi-sensor may be required to improve the signal detection and the localization from the multi-ED source concurrently. Okay, furthermore, the implementation may require high cost for new upgrading work and the installation to replace the existing monitoring system. Next is the objective of this work is to develop a novel perceptron-based UHF smart sensor called Single Perceptron Smart Sensor (SPSS). It utilizes a single perceptron artificial neural network algorithm, and it is integrated with a two-element linear array antenna to smartly localize the impulsive signal of corona and arc discharge. At the same time, it will suppressing the cost and the complexity of the pre-monitoring system, thus providing a speedy localization within seconds. So based on the review that I have made, corona and arc discharge is represented as ED, electromagnetic pulse, or EP, with a UHF frequency at the range of 300 MHz to 3 GHz. And then for the UHF sensor, a small size ultra-wideband linear array antenna is used due to the wide coverage and less complexity. And then for the perceptron artificial neural network algorithm, an adaptive ANN algorithm is developed to electronically smart beamform a linear array antenna radiation. And then as for the signal recognition, it involves a waveform-based model for the electromagnetic pulse signal, allow identification using a single source of ED signal to avoid extensive data samples. Okay, next is the comparison of localization method. As we can see from the table, I have summarized 4 methods that are usually used in partial discharge or electrical discharge localization technique. Okay, the first one is RSSI. So this RSSI is fingerprint received signal strength index. When we use this method, it requires a fingerprint map by a site survey before we do the partial discharge localization. And therefore, putting this substation at the risk of service. We need to shut down the substation in order to survey the site for the fingerprint map. Okay, the second one is time of arrival. So time of arrival, or TOA, require the distance between the target and the sensor by measuring the time that required for the signal to travel. Okay, so the third one is time different arrival, which is TDOA. For this technique, is slightly different from TOA, which for TDOA, it requires multiple sensor. Okay, the application of multiple sensor, and it works well for the localization or monitoring application when there are numerous of sensors are applied widely scattered at the wide area space. Okay, and then the last one, which is the focus of my work, which is the method that I apply in my work, which is a direction of angle, or DOA. So DOA provide low complexity and cost efficiency. Okay, it can be used with a single sensor source localization or resource constraint application. So we do not have to use multiple sensor in order to do the localization or monitoring. Okay, so therefore in this project I choose DOA because of low complexity and cost efficiency. Okay, next is the methodology. I have summarized the methodology in the form of a diagram. As we can see that from the figure is the overall model of the SPSS, which is mounted on an indoor substation. Okay, so the ED electromagnetic pulse signal is represented in EP, is generated from a power transformer, and the direction of localization, which is the DOA, is represented as theta m in angle of degree at the detection distance in meters. Okay. Okay, next is the ED localization analysis finding that I have done. From the polar plot, we can see that the response of the SPSS representing the radiation pattern of the SPSS in corresponding with the 4 different EP sampled at DOA of 45 degree, 120 degree, 225 degree, and 300 degree. Okay, from the result we can see that the SPSS is significantly localized, the EP, from these 4 different DOA. Okay, each of the beamform responded to the subject of DOA. Okay, this is the comparison table that I have made. A comparison of ED localization for multi-range of ED sources is made based on a numerical difference of localization error measured in degree. Okay, all the best method ED localization is reviewed for UHF frequency ranging between 300 MHz and 1.5 GHz, 2 and ultrasonic frequency range of 50 kilohertz to 150 kilohertz relatively, and the ED localization falls between 2 degree to 6 degree overall. Okay, so from the table it indicates that SPSS localization is compared to other method while employing the same localization, which is DOA method. As we can see from the table, that despite of having different sensors of localization, the average error of SPSS exhibits a significant comparative performance among the localization work. Okay, so the SPSS shows that the localization average error of 2 degree, although only 2-element array antenna have been used in the system. As conclusions to my work, a pre-fault monitoring system is successfully developed utilizing new SPSS for corona and arc electric discharge localization. The novelty of this work is that the SPANN algorithm has replaced the use of a phase shifter to shift the array antenna electronically, thus suppressing the cost and the complexity of the localization system, providing a speedy localization within seconds. Lastly, the accuracy of the pre-fault monitoring system tested for the corona and arc electric discharge at the sampling frequency between 300 MHz to 3 GHz. The SPSS has revealed an average error of the localization of 2 degree for signal localization with minimal computational complexity. Well, it comes to the end of my presentation. Thank you for your time, and hopefully my contribution to the board of knowledge is acceptable. Thank you so much.